Okay, let's start with the molecular structure of peptides. Well, let's explore the intricate levels of peptide structure and their significant roles in cosmetic formulations. I believe understanding these structures helps us appreciate how peptides function and why they are so effective in skincare products. For instance, the primary structure. The primary structure of a peptide is the fundamental sequence of amino acids linked together in a linear chain. Imagine it as a string of beads, where each bead represents an amino acid. For example, consider the tripeptide GHK, which stands for gly-his-lyse. This specific sequence of amino acids is crucial because it dictates the peptide's basic properties and its biological activity. In cosmetics, this means the primary structure determines how the peptide will interact with the skin, what kind of signals it can send, and what effects it can produce. For instance, GHK is known for its role in skin regeneration and repair, making it a valuable ingredient in anti-aging and wound healing products. Next, we see secondary structure. The secondary structure refers to the localized folding or coiling of the peptide chain into structures like alpha helices and beta sheets. These shapes are stabilized by hydrogen bonds, which act like tiny Velcro strips, holding the peptide in a specific configuration. This structural stability is crucial because it influences the peptide's resilience and functionality in cosmetic formulations. For example, an alpha helix structure can enhance the stability of a peptide, making it more resistant to enzymatic degradation. In skincare, this means the peptide retains its effectiveness longer, even when exposed to the complex environment of the skin. By incorporating peptides with robust secondary structures, formulators can create products that deliver sustained benefits, such as prolonged hydration, improved skin elasticity, and reduced appearance of wrinkles. Next, when we delve into the tertiary structure of peptides, we're talking about the three-dimensional shape that a single peptide chain folds into. This structure is crucial because it's influenced by the interactions among the amino acid side chains, which can include hydrogen bonds, disulfide bridges, ionic bonds, and hydrophobic interactions. For cosmetic formulators, understanding the tertiary structure is particularly relevant when working with longer peptides and small proteins, as this 3D configuration determines how the peptide functions within a formulation. For instance, a peptide's ability to interact with skin receptors or its stability in a cream or serum can be heavily influenced by its tertiary structure. This structural level can affect everything from the efficacy of an anti-aging peptide to the stability of a peptide in a moisturizing product. Moving on to the quaternary structure, this refers to the way multiple peptide chains or subunits come together to form a larger complex. While not as commonly discussed in the context of cosmetic peptides, which are usually shorter and function as single units, understanding quaternary structure is still valuable, especially when dealing with larger protein complexes that may be incorporated into advanced formulations. For example, consider a complex protein like collagen, which is composed of multiple peptide chains wound together. Grasping the intricacies of quaternary structure helps in formulating products that aim to mimic or support the skin's natural protein structures, offering more advanced anti-aging and skin repair benefits. So basically, for any advanced cosmetic formulators, appreciating the structures of peptides can provide deeper insights into how these molecules behave in formulations.